Boys and girls, Mr. Manise here again with another super cool video, and in this video I'm going to walk you through how to solve each of the questions on our rational expressions quiz review. My disclaimer as always, need you guys to work these problems on your own and then come to the website in the video to see where you might have made a mistake or to clarify any misunderstandings that you have. Before I get into working these problems, this is pretty tricky stuff. This whole unit, polynomials, especially with the rational expressions, is probably the most difficult material that we cover in advanced algebra. So I'm going to take a few minutes here and just to refresh your memory on how we get a common denominator when we add and subtract these rational expressions. If you're 100% secure and confident in that concept, then go ahead, feel free to fast forward until we get to number one. But if you think you need a few minutes on common denominator, take off your shoes, kick up your feet, and stay a while. So what do we do when I have 1/2 plus 3/4? When I am adding and subtracting, I have to get a common denominator. If I'm multiplying, then you just multiply across the top and the bottom. But here, I've got to get a common denominator. Okay, so one thing that you can do is just to say, will the little guy divide evenly into the big guy? And in this course, yes, of course, 2 divides into 4. How many times? It goes into it 2 times. But I'm going to offer a different way to think about this. I could also rewrite this as 1/2 plus 3 over 2 times 2. Can I not do the same thing? That's still the same thing as 3 over 4. But notice now that we're trying to get a common denominator. What do these things have in common? Okay, they both have a 2 here in common. So if I pull out a factor, or in just a minute you'll see we're pulling out a GCF, then I have a factor, or I have a number, a term that's in common with both of these guys. Okay, so going back to this original expression, 2 goes into 4 2 times, which means the common denominator is 4. Okay, so I need to, what do I have to do to this denominator to get it to be 4? I need to multiply it by 2. Okay, so I would multiply this fraction by 2 over 2, which is just 1. Okay, when I multiply those, I get 2 over 4. And of course, 2 over 4 is the same thing as 1/2. Okay, now I can add that to 3/4, add across the top because I have a common denominator, and that becomes 5/4. Okay, but if I go back over here, when I break it down into its factors, then you can kind of think of it this way. Both of these, you can kind of think about these as both of these just kind of canceling each other out. Okay, they're both common, okay, to both of those denominators. So what's left over is this guy right here, the 2. Maybe I should put that in a box. I'm left with the 2. Okay, so now I don't have to do anything with this fraction because I have the 2. What do I have to do to this fraction? I'm missing this guy. These 2's are already kind of canceled out, but I'm missing a 2. So I'm going to multiply the top and the bottom by 2. Okay, which is the same thing I did over here. I'm just offering you a different way to think about common denominators. With numbers, single numbers is easy, but when we're talking about expressions with variables, sometimes it gets a little bit more confusing. Okay. And of course, eventually I'd get the same answer. Let's look at another example. What if I had x plus 3 over 4 plus x minus 2 over 4x plus 8? Okay. How do I do this? Well, I want to see if they have something in common. Okay. Of course, you guys can just look at that immediately and say, both of these are divisible by 4, and this has a 4, so yes, they have something common. But just like back up here, when I broke down 4, I broke that down into 2 times 2. I'm going to do the same thing down here in this fraction. I'm going to leave this guy alone, and I'm going to break this guy down into, I'm going to pull out a GCF of 4, and that's going to leave me with x plus 2. Okay, so just like up here, I broke this down into 2 times 2, and we said this 2 and that 2 kind of offset each other. Well, it's the same thing here. It's kind of like these 4's kind of offset each other. My common denominator is 4 times x plus 2, or multiplied out 4x plus 8, because they both have a 4 in common. Okay, but now I'm left with this x plus 2 piece. Just like up here, I was left with a 2. I need to multiply this by 2 over 2. I'm left with this piece, x plus 2. That means I need to multiply this guy by x plus 2, the missing piece. Okay. Or the other way is to think about, what do I have to do to this 4 to get it to look like 4x plus 8? I have to multiply it by x plus 2 to get it there. And then I would go about foiling this out, etc. But my common denominator on both of these fractions would be the 4 times x plus 2 in both cases. Okay. All right, last example. Let's say I have something like this. What if I have x minus 1 over x plus 5 minus 6 over x minus 2? Something like that. Okay, what do I do? What is common to both of these guys? Okay, well, let me offer you this. 1/2 plus 1/3. Okay, what is common to 2 and 3? Nothing. There's nothing I can pull out except a 1, and you can always factor out a 1 from anything. So there's nothing common. So what do we do here? I need to multiply these guys together. Okay, so the common denominator would be 6. That means I need to multiply this guy by 3 over 3, the missing piece. Okay, the common denominator would be 6. I can break that down into 1 over 2 times 3. Okay, this has the 2, but it's missing the 3, so I need to multiply by 3 over 3. This guy has the 3, but it's missing the 2, so I need to multiply by 2 over 2. Okay. All right, but down here, I don't have anything in common. So up here, what do we do with the 2 and the 3? We multiply them together to get our common denominator. Here, I'm going to multiply those together. So my common denominator, CD, is 2 times 3. 2 times 3. That guy times that guy. X plus 5 times x minus 2. This guy has the x plus 5. It's missing that piece. So I need to multiply this by x minus 2 over x minus 2. This guy is missing that piece, so I need to multiply this guy by x plus 5 over x plus 5. Okay, and then of course I would go on to FOIL and distribute and solve. But I just really wanted to hammer home that point of how you get the common denominator when you're adding and subtracting these rational expressions. All right, without further ado, let's just jump on in. Okay, these first couple, they just want us to simplify. Okay, there's no operation here. There's no plus sign, there's no minus sign. Okay, down here we actually have operations, but here I'm simply going to simplify this rational expression. So I'm looking to see what goes into 63 and 81. Right, they're both divisible by 9. So if I divide the top of the, and I kind of do these one at a time, just kind of look at the fraction. How would you simplify that fraction? Divide the top and bottom by 9. That's going to simplify to 7 over 9. And then I kind of look, I don't look at the numbers anymore. How do I simplify b over b squared? Okay, one way is to just subtract the exponents, or the other way to think about it, hopefully you were taught this way. This is b over b times b, and those cancel out. I'm left with 1b on the bottom. Okay, so my final answer, b over b squared is just a b on the bottom. So my final answer is 7 over 9b. Okay, in this one we're going to have to do a little bit of factoring to simplify. So I'll kind of treat these one at a time. Can I factor the top? How would you factor that quadratic? What are the factors of -6 that add to 1? The middle term, that's going to be 3 and 2. So this is going to factor as x plus 3 over x minus 2. All right, how do I factor the bottom? Okay, this is a difference of squares. That's going to factor as x plus 3. One's positive and one's negative, x minus 3. Okay, and now I'm looking to see, can I cancel anything? I've got an x plus 3 on top and an x plus 3 on the bottom. So those guys cancel out, and I'm simply left with the numerator x minus 2 over x minus 3. Okay. Now, notice in the directions, guys, it says to state the excluded values. On this quiz review, you're only asked to do that on 2 of these problems. We don't ask anywhere else. However, on the quiz, almost every problem, we're going to ask for these things called excluded values. All right, so to keep the confusion to a minimum, I'm going to try to explain it this way. I'll offer you 2 ways to think about it. One way is to say, what does, if I have a variable, you can only have an excluded value if you have a variable in the denominator. Okay, if I just have some expression x minus 2 over 4, there is no excluded value. An excluded value means that you have a number that you can substitute in for the variable that will create a 0 in the denominator, which we can't have. I can never divide anything by 0. That's undefined. Okay, so in other words, what number can I stick in for b that will cause this to be 0? Okay, and a lot of you guys can look at that and say 0. Any other number, if I plug in 1 for b, -1,000,000, any other number will give me some value in the denominator, which is acceptable. Okay, but you look at that and say 9 times 0 is 0. Another way to think about it, if you're struggling with excluded value concept, I want you to think about literally setting the denominator equal to 0. What does b have to be to make it 0? Well, if I get b by itself, divide both sides by 9, the 9's cancel, and b is 0 over 9, which is 0. Okay, and so just like we said, the EV, excluded value, is going to be 0 for this question. Okay, let's go back over here. What is my excluded value? Now I will tell you from experience, the main tripping point and the main mistake that students make is they look at the final answer to get their excluded value. Guys, you cannot just look at the final answer. You have to look at every step throughout the process, through the problem, to figure out where can I possibly have zeros in the denominator of any fraction. Okay, they could be in fractions when you're dividing before you flip the fraction. You got to look everywhere. Okay, so if I look at the final answer, I say, okay, what does x have to be to make this denominator 0? Well, literally set this equal to 0, move the 3 to the other side, and I get 3. So you would say the excluded value is 3. That's correct. However, if we look back up here, after we get this to factored form, notice that if I were to set this denominator, if I were to set the whole thing, or actually we can go all the way back to quadratics. I'm literally going to set this denominator, I'm going to set this quadratic equal to a purple pen that will work. Okay, x minus 9, set that equal to 0. How do you solve that? That's the difference of squares. X minus 3 times x plus 3 equals 0. What do you do? Flippy flip, right? We flip the signs. X will be equal to 3 and negative 3. And it's no different up here. What do I have to substitute in for x to get a 0? 3 or negative 3. If I plug in a 3 right here, just this piece, 3 minus 3 is 0. And 0 times anything, I don't care what this is in the denominator, 0 times anything is going to be 0. Well, if I plug in a negative 3 to this piece, negative 3 plus 3, that also gives me a 0. And 0 times anything gives me a 0 in the denominator. So my excluded value in this case are both of these guys, 3 and negative 3. And guys, you can have a bunch of excluded values, okay, just depending on how complicated the problem is. Okay, so that's simplifying. Let's go ahead and jump down to multiplying and dividing, which is pretty easy. Usually you think adding and subtracting is the easiest, but rational expressions and fractions is actually more difficult. Okay, when I see the little dot, that means multiplication. That means I'm multiplying across the top and I'm multiplying across the bottom. Okay, but before we do that, guys, you always want to see, is there anything that I can cancel to make my life easier? Okay, so if you notice that there's a 6x plus 6 on top and a 6x plus 6 on the bottom of this fraction, and some of you guys may look at that and say, well, wait a minute, I can't cancel that, right? Because this one's over here on the right, this was over here on the left. Well, let me offer this to you. 2 times 3 times 4 times 6, okay, over 4 times 5 times 8 times 2, okay? There's a 2 and a 2 on the top and the bottom. When you're multiplying things together, when you're only multiplying, okay, multiplying, then it doesn't matter where I cancel. It doesn't matter where these things are. It doesn't matter the order. Okay, I can cancel the 4s and I can cancel the 2s. Okay, it's the same thing up here. I'm multiplying all this stuff together. Yes, you could think about putting these in parentheses, absolutely. I'm multiplying those expressions together, but I'm still multiplying this thing times this thing over this thing times this thing. Okay, that would be like 2 times 3 over 3 times 4. Okay, these 3's will cancel. So these guys will cancel. Okay, it doesn't matter the position. All right, now I want to see, can I factor the top or the bottom? Okay, can I factor this trinomial? Are there any factors of 12 that add to 8? Yes, there are. That's 6 and 2. So on the top, I'm going to be left with x plus 6 times x plus 2. And that's going to be over this leftover denominator, which is 6x plus 12. And I'm still not done yet. I can still factor the denominator. I can pull out a GCF. So that's going to be x plus 6 times x plus 2 on top. If I pull out a 6, that's going to leave me with x plus 2. Okay, oh, now look. Now the x plus 2's will cancel and go away. And I'm simply left with x plus 6 over 6. Okay. All right, now it doesn't ask for EV, but what would the EV be? EV be? Okay, nothing, because there's no variable in the denominator. Okay, so move on to the next one. All right. And by the way, guys, you can check every single one of these on your calculator. I'll do a couple here in a minute just to show you how to check, but you guys should be familiar with this by now. All right, now this is division. See that bad boy right there? We're dividing. Okay, so I'm taking a fraction divided by a fraction. Now it's written this way, but I could also divide fractions like this. I could have 1/2 divided by 5/6. Okay, how would I divide this fraction by this fraction? How would I divide this fraction by this fraction? What do? You multiply by the reciprocal. So it'd be 1/2 times 6/5. okay, multiplied by the reciprocal, which would be 6/10, 3/5. Okay, all right, same thing down here. Okay, I could have stacked this fraction underneath here, but they've written it this way. So all I'm going to do is I'm just going to multiply by the reciprocal. I'm going to flip this second fraction. So I'm going to keep this first fraction, a squared plus 8a plus 16 over a plus 4. And now I'm going to multiply by the flip. 4a plus 24, that guy goes on top, and the 4a plus 16, that guy goes on the bottom. Okay. All right, multiply by the reciprocal. Okay, so now, is there anything that I can cancel? Okay, well, I always like to start with the binomials. Okay, we can go ahead and factor the trinomial. We can go ahead and do that first. That's no problem. Let's go ahead and factor this numerator. A squared plus 8a plus 16. What are the factors of 16 that add to 8? 4 and 4. Now, normally we would write this as a plus 4 quantity squared. I'm going to go ahead and separate it. My pen. Gotta have a pen real quick. Yeah, it's more better. All right, I'm going to go ahead and separate this into a plus 4 times another a plus 4. Okay, instead of writing a plus 4 squared. And the reason why I'm doing that is because I want to be able to see each of these binomials separately so that I can figure out whether or not I can cancel one of those guys. All right, so I got a plus 4 times a plus 4 over a plus 4 times, let's go ahead and pull out a GCF here, 4, that's going to leave me with a plus 6, over, pull out a GCF here, 4 times a plus 4. Okay. All right, so there were questions in class about if I just look at this guy right here, okay, can I cancel all of these? I got an a plus 4 everywhere. And the answer is no, you can't cancel all those. Let me explain why. What if I had 2 times 2 over 2? Okay, I can't just cancel all those because if I cancel all those, I'm left with 1. And clearly that's not true because 2 times 2 is 4 over 2. That actually equals 2. Okay, in this case, I can only cancel one of these guys. Okay, cancel one of those guys, and I would be left with 2. It's the same thing down here. I can only cancel one of these parentheses. So one of those guys goes away. However, I still have another one down here. So in this case, yes, I can cancel all 4 of those guys. That would just be like 2 times 2 over 2 times 2. Okay, they'll all go away. All right, this 4 and that 4 cancels. Okay, and I'm simply left with a plus 6. Okay, that's my final answer. Now, I'm going to ask, it doesn't ask for the EV, but I'm going to ask you for the EV on this one because this is pretty tricky. What are my excluded values, value or values? Okay. Remember, you've got to go to every step in the process. I'm going to go all the way back up to the original problem here. If I have an a plus 4, if I literally set that equal to 0, then of course one of my excluded values is going to be negative 4. Because some of you guys will look at your final answer and say, I don't have any excluded values because I don't even have a fraction in my final answer. And that's true. That's why you got to go back and look at every step of the process. Okay. Some of you guys might go back to this point and say, okay, my EV is negative 4 because a negative 4 there or a negative 4 there gives me a 0 in the denominator. That's true, but you have to go all the way back to the original problem. Okay, so before we flipped this fraction, this 4a plus 16 was in the numerator, but now it's in the denominator. So I've got to set that guy equal to 0. Okay. So that's going to be 4a equals negative 16 divided by 4. So I also have a negative 4 there, which is correct. In this case, it doesn't really matter because one of our EVs was already negative 4, but you have to go through this process. Now, after I flip the fraction, now this 4a plus 16 is on the bottom, and the 4a plus 24 is on the top. So I have to look at this guy as well, 4a plus 24. And set that equal to 0. 4a equals negative 24 divided by 4. In that case, I get a negative 6. Okay, so my EV would also be negative 6 in this case. Okay, now we're not being asked to do that, but I'm just trying to show you guys, you got to look at the denominator of that fraction. You got to look at the denominator after you flip it. You got to look at that guy every point during the process. Look for those excluded values. Okay, and those excluded values, when we get to graphing and solving equations, they're going to have very, very significant a lot of importance when we get to graphing these things. That's why we need to learn them now. Okay, so now we're down to subtracting. Okay, we're done with dividing, we're done with division. Now we're down to these two problems, and everything on the back here, that's plus and minus, okay, adding and subtracting. So now we're back into common denominator land. They were nice to you on this one. They already have a common denominator. All right, so all I need to do is basically just combine my like terms on the top, okay? But I hope you guys remember what I said in class. When there's a minus sign, when you are subtracting, and you have more than one term in the second or third fraction, you must put that in parentheses. Okay, so this is going to be x plus 3 over 9x squared minus 27x. And I'm basically just combining all these together because this is my common denominator. So now it's going to be minus, you got to distribute your negative here. Distribute there and there. Okay, so that's going to become a minus x, and that's going to become a minus 5. And all of that is over my common denominator of 9x squared plus minus 27x. Okay, so on top, the x minus x cancels, and I'm going to be left with 3 minus 5, which is negative 2, over my common denominator of 9x squared minus 27x. Okay, now I already know nothing's going to cancel because they only have a number on top, but we still need to pull out a GCF to get it into fully simplified terms. So on the bottom, I can pull out a 9x, and that is going to leave me with x minus 3. Now that is a fully simplified answer. Okay. All right. So let's move on to the next one here. What would my EVs be on this one? Okay. If I set 9x squared minus 27, if I set that equal to 0, then I'm basically going to end up with this. I'm pulling out that same GCF, x minus 3. Okay, so one of these guys, how would I solve this? If this were a normal quadratic that we learned how to solve last year, how would we solve it? Well, I'm going to set this guy equals 0, 9x equals 0. So one of my EVs is 0, and then this guy, I just flip the sign. So my other EV would be 3. Okay. All right, number 6, I need a common denominator. All right, do they have anything in common? Can I pull out anything from 5x squared that will have something in common with 3? The answer is no. So what do? I multiply these two together. So my common denominator is going to be 3 times 5x squared, which is 15x squared. Okay, so now that the denominators are different, I got to look and see, okay, what is this piece missing? What do I have to multiply 3 by to get 15x squared? And it's going to be this guy. I need to multiply, let me rewrite the problem. I need to multiply this fraction by the missing piece, just like I talked about at the beginning of the video. Okay, what do I have to multiply this guy by to get 15x squared? I have to multiply it by that missing piece. This guy needs the 3 over 3. This guy needs the 5x squared over 5x squared. Notice that 5x squared over 5x squared and 3 over 3 is just 1. So I'm multiplying by a big fat 1. I haven't really done anything. Okay, but now that allows me to get a common denominator. So I'm going to multiply across the top. 5x squared times 6x is going to give me 30x to the third. Okay, 4x times 3 is 12x, but remember that's a minus sign there. I don't have to distribute anything because I only have one term. So this is just minus 12x. And then now it's over my common denominator of the 15x squared. Okay, but I see x's everywhere, okay? 3's, everything's divisible by 3, so I know I can at least pull out a 3. Can I do anything better? 4, no. 6, I can pull out a 6 from the top. So if I can factor out, that's got 3 x's and that's got 1 x, so I can only pull out a 6x. That's going to leave me with 5x squared minus 2, minus 2 over 15x squared. Okay, now notice 6 and 15 are both divisible by 3, right? How would you, if I just gave you a fraction, said simplify 6 over 15, how would you do that? Divide by 3. Okay, so that's going to be 2. And then also notice I've got an x here and x squared down here, and that's like this one up here. B over b squared was a b on the bottom. X over x squared is an x on the bottom. So this is going to be 2 times the rest of the numerator. If I divide that by 3, that's going to give me 5, and I've got an x on the bottom. So my final answer is 2 parentheses 5x squared minus 2 over 5x. All right, let me show you guys real quick how to do this on the calculator. I'll do an easy one like this one. I'll do a hard one on the next one. Okay, now the trick, guys, with this, and admittedly, these are a little bit cumbersome. Yeah, it takes a little while to type these into your calculator to guarantee that you got it right, but I'm telling you guys, a lot of you guys turn in your quizzes with 10, 15, 20 minutes to go in class, and I never understand why students won't take just a few minutes and plug this in and guarantee that your answer is correct. You've got a winning lottery ticket. Well, I wouldn't turn in my quizzes and tests until, if I had a teacher that taught me this trick, I would never turn anything early unless I guaranteed I've checked every single one or until the bell rang, one of those two. Okay, so on this one, let's do an easy one. Let's type in what we see. Now, parentheses are going to be very, very important with all these fractions, okay? This first one, I'm going to type parentheses 6x, okay, divided by, I don't need parentheses on the bottom because it's only one thing. It's just a number, okay? Let's put that in parentheses. That whole quantity, I'm going to subtract parentheses, okay, 4x divided by, now do I need to put the 5x squared in parentheses? Think about that for a second. Yes, I do, okay, because there's more than one thing. Okay, I've got a number and a variable, okay? So I need a set of parentheses, 5x squared, close that parentheses on the 5x squared, and close that parentheses on the whole second fraction, okay? I'm going to press enter, I'm going to get a number. Okay, watch what happens if I didn't put the 5x squared in parentheses. 6x divided by 3 minus 4x divided by 5x squared. Okay, I don't get the same number. Why not? Order of operations. Your calculator sees this as 4x divided by 5. It's going to do that division first, and then it's going to multiply by x squared. So in other words, that x squared is on top. You've got to tell it, no, I want you to divide this whole thing by quantity 5x squared, okay? So don't forget that. All right, so here's our original number, 19.92. Don't care what that number is. We think that's equivalent to, all right, now I'm going to need two sets of parentheses here because I'm multiplying two things in the top. So 1, all right, here's my second set of parentheses, 5x squared minus 2. Close that parentheses, close that parentheses. I want all that whole thing divided by 5x in parentheses. You know it. Got to put that in parentheses. Oh, look, they both match, and I guaranteed I've got it correct. Now, that doesn't guarantee that you fully simplified it, but it guarantees that you haven't made a mistake, okay? So please take those few extra seconds. I don't care if it takes a minute to plug it all in. You know, why would you not want to do that to save yourself from missing 5, 10, 3 points on the quiz or test or whatever it may be? That's why I love math. I mean, you can check your work, and even more so in advanced algebra. In geometry, there wasn't a lot of stuff that we could check because it's angles and parallel lines and theorems and proofs. Advanced algebra, man, you can check almost everything that we do outside of the first unit with statistics. All right, let's go to the back. Common denominator, because I'm adding. Is there anything common between those? No, I got to multiply them together. So my common denominator is going to be p plus 1 times p plus 2. Oops. Okay, so what is this guy missing? Let me rewrite this. Okay, this guy is missing what? It's missing this piece. So I need to multiply that by the p plus 2 over p plus 2. What is this guy missing? It's missing that piece. So I need to multiply that by p plus 1 over p plus 1. All right, now here I need to distribute there. I'll put that in parentheses if that helps you. 3 times p is 3p. 3 times 2 is 6. All right, over here, I'm going to add that to 6p times p, 6p squared, and then distribute to the 1. 6p times 1 is 6p, and all of that is over my common denominator of p plus 1 times p plus 2. Okay, I can put all this together on top because now this is just combining like terms. I'm just adding all this stuff together. All right, so I'm going to have a 6p squared, add this 3p and the 6p, plus 9p plus this 6, and all of that's over my common denominator. Okay, we're not done yet. I might have something that cancels. I see everything is clearly divisible by 3, so let's pull out a 3 on top, and that's going to leave me with p squared plus 3p plus 2 all over, or excuse me, 2p squared plus 3p plus 2 all over p plus 1 times p plus 2. Now some of you guys might look at this, I hope you do, and say, I wonder if I could factor this by grouping. Could I do the rainbow thing? By the way, this is our final answer. Could I do the rainbow thing? If I multiplied, forget everything else. How do I factor this? Okay, could I do the rainbow thing? 2 times 2 gives me 4. What are the factors of positive 4 that add to positive 3? There aren't any. I got 1 and 4 and 2 and 2. Neither of those get me to 3. Okay, so this is it. That is my final simplified answer. Okay, let's check this one on our calculator. Okay, need lots of parentheses because I got binomials in the denominator. So parentheses 3 divided by another set of parentheses. Now here's another trick, guy. The reason I taught you guys how to assign numbers to all these letters on your calculator, all these green numbers, is so that you have, in the case you have more than one variable, if you're dealing with x's and y's, or maybe even x, y's, and z's, so you don't have to keep track of what number you're assigning to. If there's only one variable, guys, just use x. You don't have to use p. All right, we don't care what the number is, so I'm just going to use x. All right, so x plus 1. All right, close that. All right, 2 sets of parentheses, all of that, plus, oops, shoot, do that again. Or I could just keep going. I can just do answer plus, all right, parentheses 6x divided by another set of parentheses, x plus 2. Close both of those sets. Okay, that gives me that number. Okay, don't care what the number is. We think that's the same as all of this stuff. Okay, parentheses 3. Another set of parentheses. Remember, we're using x's. 2x squared plus 3x plus 2. Close both of those parentheses. Divided by 2 sets of parentheses. X plus 1. Close that. Open another one. X plus 2. Close both of those. Drum roll. Boom. They match. So I know I didn't make a mistake. And yes, they have to match verbatim. Every single number has to match. All right, check that off the list. Guaranteed you got it right. Move on to the next one. Love it. All right, common denominator. So this is one that I was showing you guys at the very beginning of the clip. You guys may look at that and say, well, they don't really have anything in common, so I'll just multiply them together. However, if I pull out a GCF here, I'm going to do this up here. 3n minus 9. If I pull out a GCF, that's going to leave me with 3 times n minus 3, correct? Okay, so I've got a 3 and a 3 times n minus 3. So they both have a 3 that's in common. Okay, so that means I can leave this guy alone. This is the common denominator. 3 will divide evenly into 3n minus 9. How many times will 3 divide into 3n minus 9? It will divide into it n minus 3 times. Okay, so this piece I can leave alone. This piece needs what? I already have the 3. This piece needs the n minus 3. Okay, so if I multiply that times n minus 3 over n minus 3, okay, so I've got 4n. Now I'm going to go ahead and break it down so you can see 3 times n minus 3. That's our common denominator. Okay, so now on top I'm going to have to FOIL this out. Okay, I'll do this kind of off here to the side. FOIL first, outside, inside, last. Okay, combine my like terms, that's n squared minus n minus 6. Okay, so that's going to be plus this guy, n squared minus n minus 6, okay, all over the common denominator, 3 times n minus 3. All right, now they're common denominator. Now I can combine these. So on top, I'm going to have the 4n plus n squared minus n minus 6, all that over a common denominator of 3 times n minus 3. Okay, let's clean this up a little bit. So on top, I can combine the 4n, the negative 1n, so I've got n squared plus 3n minus 6 all over 3 times n minus 3. Okay, can I factor this? Are there any factors of negative 6 that add to 3? Nope. 1 and 6 won't get me there, and 2 and 3 won't get me there. Okay, so that's it. That's our final simplified answer. Check it on your calculator. Okay, what if I ask you for EVs in this one? Okay, my final answer, I would have an EV of what? 3, right? Because that gives me a 0 in the denominator. What about any point during the rest of the problem? 3, 3, 3. What if I plug in a 3 right here? 3 times 3 is 9. 9 minus 9 is 0. So the only EV in this case would be 3. Okay, let's keep going. All right, now this one is r plus 3 squared, quantity squared on the bottom. So I'm going to rewrite this as 4r over r plus 3 times another r plus 3, just so visually we can see what are we missing, what do we need. Okay, does r plus 3, does the little guy go into the big guy? Does r plus 3 go into r plus 3 times r plus 3? Yes. How many times? R plus 3 times. 1 over 2 times 2 plus 3 over 2. Okay, how many times does 2 go into 2 times 2? These cancel out. It goes into it 2 times. Okay, so my common denominator is the r plus 3 times r plus 3, which means I can leave this denominator alone. What does this guy need? It's missing one more r plus 3. Okay, so this one I leave alone. 4r over r plus 3 times r plus 3. And here I'm going to distribute. 5r times r is plus 5r squared. 5r times 3 is plus 15r. All of that over our common denominator of r plus 3, r plus 3. Okay, let's clean this up a little bit. I can add the 4r and the 15r. So I have 5r squared plus 19r over r plus 3 times r plus 3. Okay, nothing's going to cancel, but I can pull out an r. So that's going to leave me with 5r plus 19 all over r plus 3. Now in this case, if you want to leave your denominator as this, if you want to leave it as quantity squared, I'm perfectly fine with either of those acceptable answers, whichever you prefer. Okay, number 10. Okay, 6m over m squared plus m minus 6 and m plus 3. So anytime I see a quadratic trinomial on the bottom of these rational expressions, I'm always going to see if I can factor it. How does m squared plus m minus 6 factor? Factors of negative 6 that add the positive 1 are going to be 3 and negative 2. So that's going to factor as m plus 3, m minus 2. Okay, so I'm going to rewrite this as 6m over m plus 3, m minus 2 plus another 6m over m plus 3. And now you can see, oh, okay, they both have something in common. They both have an m plus 3. And this fraction is missing the m minus 2. The common denominator is m plus 3 times m minus 2. Okay, so I can leave that guy alone. Okay, what is this piece missing? It's missing, I'll put brackets there, it's missing an m minus 2 over m minus 2. Okay, so if I distribute here, 6m times m, remember we're adding all this together, it's going to be 6m squared and then 6m times negative 2 minus 12m over the common denominator. And now I can clean this up. I can combine these guys on top. So I have 6m squared, 6m minus 12m, it's minus 6m, and that's over our common denominator. Alright, on top, what can I factor out? I can factor out a 6m, and that's going to leave me with m minus 1. So nothing cancels, that's okay. That is our simplified answer. What would my EVs be? Look at throughout the whole problem. Throughout the whole problem, it's just an m plus 3, m minus 2. So my EVs will be flippy flip, negative 3 and positive 2. Alright, and that's going to do it for this video, guys. Mr. Manise, what about number 11, 12? Yeah, so about that. I'm purposefully not going to work these out on the video because wink, wink, hint, hint. These might be a bonus on the quiz. So I'm not going to work out these problems because I'm basically going to be working out the bonus for you, and that defeats the purpose of having a challenging bonus to see if you can figure it out on your own. But I will give you one little tip. You got fractions over fractions, fractions over fractions. Treat these like individual problems. Treat that as a problem, and then treat that as a problem, and then go from there. Alright, so I hope you guys enjoyed this video, and remember to check these things on your calculator. We will see you on the next video.